How do? Yay. Okay. I think we are live-ish. All right, let me turn some stuff off. Let me tweet about this. Yay. Okay. Da, 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 da. Where is my Twitter? I got new overlay, so I'm very proud of this. If you're watching stream right now, there's like a thing here. Tweet. Live now. Rust 1.41 patch review. TV/my name. Okay. Wait, hold on. Let's make sure I don't have anything important open. Going live in what? A minute? Maybe? Oh, wait, patch notes. Yes. Great. Okay, this is what I wanted. Okay. Hey. Welcome everyone to the stream. All two people of you right now tuning in. Okay. Yeah. So today I was thinking, like, let's just go over patch notes. A bunch of stuff changed in Rust 1.41. Wait, hold on. Yeah, okay, no, this works. Oh, cool, sweet. Hi, Julian. Welcome. So yeah, a bunch of stuff is new in 1.41, and I figured it'd be fun to go over that. There's some more details and whatnot. Yeah. I guess let's just dive in. Yes, great. Okay. So announcing Rust 1.41. This patch came out yesterday, and it's I don't know. I don't know what to say here. Yeah, a bunch of stuff is new. So these patches come out like every 6 weeks. Oh, I should have prepared notes or whatever, but you know, I'm kind of reading this as you are. Actually, yeah. So yeah, patches come out every 6 weeks. On stable, nightly is a bit more frequent. This came out yesterday. So the biggest feature usually goes up top, and in this case, it's like relax restrictions when implementing traits, which is stuff around orphan rules. I can dig into like in a second. Cargo install updates packages when outdated is the second big feature. So actually, I didn't know that. Let's read it. So with cargo install, you can install binary crates in your system. All right, so it's like command line things that are installed globally. The command is often used by a community to install popular command line tools written in Rust. Yeah, that's what I said. Starting from Rust 1.41, cargo install will also update existing installations of the crate if a new release came out before you installed it. Before this release, the only option was to pass the force flag. All right, so this is really nice. Let's see, Rust up update. So I haven't actually updated my stable one. Oh, I'm on Windows new. Ooh, that's bad. All right. Rust up. Channel help. Rust up tool chain. So then we'll say something about like, yeah, Rust up default stable MSVC. Rust up update. What? Stable MSVC. All right, there we go. Okay. So I'm updating the Microsoft Visual Studio channel because I'm on Windows. So we get the latest thing. But this is really nice. So let's open up a quick little new tab here. So usually say we want to install ripgrap. Ripgrap, or actually new. New is like a new one. I'm not going to compile it. You would do cargo install new. But I think if we're still on 1.40, oh, it's succeeding. Rust C version. All right, we're already on Rust 1.41. In any case, so already I have new installed. On Rust at 1.40, if I would run cargo install new, it would fail because I already have it installed. But now on 1.41, it'll just, it just starts going. I should have prepped this a little bit better. Yeah, that's great. It's kind of like what you would expect it to do. Before that would be like, it's already been installed. I see, I have a new version available, but still not going to work. So we'd always reinstall it with -- force. And the problem with that is if you're like running it on CI or like just running it, -- force, you would just always have to pass it, and it would never do the thing where it's like, oh, I already have the latest one, I'm just not going to do anything. Yeah, so this just makes a lot of sense. All right. So the new one, less conflict-prone cargo lock format. So what they've done is, so if you like run let's go here, cargo. Let's create a new project. Cargo new. What's the? It's cargo new. Hello. All right, we're here. So yeah. So we run cargo build, and now there's a cargo lock file, and then we do open cargo lock. Does that work? Yeah, all right, there we go. This is the new lock file format. Let's do a quick thing. Cargo add async std. Does this work? Do I have Vim installed? I think I can do this. Oh. PowerShell code. All right, that works. So we have our cargo lock file. Wait, hold on. I need to explain what cargo lock is, I guess. If someone's like not aware what it is, then oh, another Walther. Well, welcome to the stream. Glad you're here. Yeah. So if we look at our cargo toml here and we say something like, let's add dependency equals 1.4.0, and then we run, where's the thing? Cargo build. Oh, exit. Or whatever. You'll see like it'll start installing like a whole bunch of dependencies. It will populate this file, which is cargo lock file. Which when this goes in, when you say async std, install async std or whatever, then it has dependencies, and those dependencies have, again, dependencies. And if your build works now, then that's great. But, okay. So what's a lock file? A lock file ensures that your build's deterministic. So if something installs today, and you got it working, then what you don't want to do is like a couple of weeks or months from now, you try running it again and it starts failing because Semver somewhere decided to upgrade a dependency, but actually that was a mistake. And now you need to like go through your application and try and debug it. Instead, the lock file allows you to lock, or sort of, I say it tracks what you installed today and will make sure that that same code will be installed at a later point in time. Which is great. And then using like upgrading dependencies inside the Semver range, you can do through cargo upgrade, I believe, which will then like bump all your deps, or cargo update, I forget. Cargo update. Yeah, there we go. That will bump all the versions in your log file. And so the new log file, like these files are intended to be checked in if you're like building a binary project. So the new log file, if you run cargo update, wait, hold on. Can we actually like show you? Git status. Oh wait, actually let's do a quick thing here. I think we had, so we do a cargo build now. I'm gonna get an old version of this thing. Target, no. New. Target. -- recursive target. I'm using new shell. Expected pattern found. recursive. All right, there we go. Now we're just gonna install old version. Also, thanks for the follow, Lemur. Yay. All right, let's see if we can actually get this to work. I want to show what a conflict thing there helps, or how that works. Next one is more guarantees when box T and FFI. Oh, that's gonna be interesting. Library changes, which I think is my favorite. We should go over these. No more Apple support. Can't show you that. Other changes. Oh, Rust, Cargo, and Clippy. Interesting. All right. Let's see if this thing has been done downloading. So still like showing the diff in the git status. Whatever. Like we just committed this. And now we're going to update our dep to 1.4. Cargo build. Cargo update or something. Cargo build. Cargo toml. Did our lock file also change? Haha. I have no idea. No idea. Git diff. Nothing changed. Cargo build. Please work. It might just be that like no deps changed. I'm not sure what the exact difference is. They just say like this is better mergeable. So I think if we look at this, then everything's more or less on one line, and everything has become a package entry, and it just feels like there's a lot of repetition, which is probably good to merge stuff. Search something like that. Cargo.lock. We can look at an existing lock file somewhere. Code. Toml. Where's Toml? Oh, cargo. Yeah, there's cargo lock. I am unsure how to find this. Maybe, I don't know. What would have it? Maybe something something parity or whatever. Just trying to think like who ships Rust binaries. Substrate is a thing, and then there is a cargo lock, which has been updated to the new version. I actually don't know. I know what the new and old versions look like. This looks like a new version. Is there like a history or something where we can like go back a week? 15 days ago. Let's check this out. Cargo lock. What does old lock file look like? Also, if Tomaka, if you're tuning in, I'm sorry I'm going through your code. All right. So if we compare this to this, then I still don't know what the changes are. It says it's better mergeable. I trust that to be the case. So package, name, version, source, checksum. Name, version, source, checksum. Ah, okay, there we go. Cool. Then the checksums are on a separate metadata line, but they have instead been moved inside of the thing here. So it's less all over the place. Okay, all right. So it's now just a field here rather than like a very long tail of here's a bunch of metadata at the tail end that contains the checksums. Gotcha. Yeah, that makes a lot of sense. So if you would update it, what you would see is you would see this number bumped, likely, or like several things bumped. And then you would see changes in the checksums and maybe changes in dependencies. That makes a lot of sense. Instead, in the past, like before 1.41, what you would see is metadata here. That just gets randomly updated and you don't really understand what's going on. Now the changes should become a lot more clear. Okay, mystery solved. That's what makes it more mergeable. Okay, yay. Right, so what happens if I just delete this and then I run? Yeah, no, I don't want to try that. All right, does that make sense to people? So that's a nice change. If you check in your like cargo log files, then that's really convenient. Cool. All right, so first two done. Cargo install package updates. Cargo lock format is done. What? If people have like any questions about anything, just like shoot. I'm not really building anything today. I'm just going over like a blog post. So that's quite easy. Yeah. All right. So this is very interesting. Thanks for the follow. Cool. So relaxed restrictions when implementing traits. So Boats made a really cool thing that they tweeted about today. Here we go. Yes. So this thing is incredibly cool. I can't follow the whole thing, but their core thing is like they can finally do something thanks to the relaxed restrictions for the orphan rules that they couldn't do before, which will create a very ergonomic and nice API. All right, so since we already have project open, let's just use this. Cool. Terminal, yay. All right, great. Okay, that's great. So the thing they're going for, or the thing this allows, all right, maybe let's start with orphan rules. The idea is that, so say we have a trait, right? Trait foo. I'm just gonna assume you know what a trait is. If you don't, like, please ask in chat, and I'm like happy to dig in further into what traits are. But like, it's the way Rust does composition. That's all you need to know for now. Struct bar, right? Then we can do impl foo for bar, and then this should compile. Cargo check. Oh God. All right, let's not do any dependencies now. Okay, cancel build. Oh, cancel. Come on, build. You stop building now. Great. Cargo check. Yeah, that works. It just says, oh, no code here. Right? That's nice. So we define our struct here. We define a trait here. Can be something like, say hello, and self, and then hello. Right, and then inside of here we can do that bar equals bar, and then bar dot hello, and this should work. See you around. Oh, Gagan says, can you increase font size, please? Yes, I can. Font, zoom in. Sorry. Oh. Is this better? Is this good enough? I'm just gonna, yeah, screw it. I hope this is good enough. Yay. All right. Sorry about that. I still haven't like found out in Windows how to automate this. I'm just like one button, let's do caster mode. I used to have that on Linux, but yeah, I recently switched, so forgive the slow workflow here. All right, so now we cargo run method hello not found. Oh, say hello. So now we have say hello implemented on bar. So now it's available because the trait is in scope, etc. So yeah, look, prints hello. And this method, or this method, comes from this trait that we implement for our custom struct right there. And you know, you can do Control++. Well, Okay. I don't know. Whoa, okay. That works. Thank you. I've also rebound my keys. So yeah, I don't know. Thanks, chat. Yeah. So where were we? Yeah. So, trait implement for that. That works fine. Now that's nice. So what happens if we have our trait here, but we're going to use a type from std? Right. So we have our struct bar still, but we're going to implement foo for not bar, but vec of t. So impl t foo. So we say we're going to implement this for a vector of type t. So it doesn't do anything either, but like it's valid, right? So this is a type that's defined in the standard library, and that's nice. Now this is valid. Valid, right? Now here comes an interesting one that says, what if we take a trait that we're not locally defining, that we're defining somewhere else? So say in the standard library, and we're going to implement it for a type in the standard library. So impl, so we're going to implement it for vec again. What are we going to implement? Something that doesn't have already. Wait, wasn't there like a little trick that we could do? Trait foo mod ich. Wait, I'm trying to come up with like a Rust vec. What doesn't vec have? Does vec have display? Can we implement display for vec without complaining? It does not have display. Great. Okay, we're going to implement display for vec. Stud font display for vec t. Oh wait, does it autocomplete? Yes, it autocompletes. Great. Results, and then we go there, and then we just whatever f.write hello or something like that. Oh, Balrog suggested hash. Yeah, that's a good one also. You just have to like look at like what doesn't it have, because check this out. This is what vec implements. That was quite a bit. Does it implement hash actually? I'm curious. Oh, it already implements hash. I guess we found the one that doesn't. For good measure, use the font like that. All right, let's see what happens here. So we do cargo run. Std vec is not defined in a current crate. There we have it. So it's not complaining about the implementation of this thing, which I think is probably okay. But it says, hey, the type you're trying to implement this trait for does not live inside of our crate, so we can't do it. So implementing a local trait that we're defining ourselves is perfectly valid for a type somewhere else. But if we don't define the trait, and we don't define the type, then that triggers orphan rules. Because what this happens is, if this was valid to implement, right? Then say patch 1.42, 6 weeks from now, someone or like the Rust team wants to stabilize or whatever, or wants to implement display for vec, then we would now have conflicting implementations, right? Because in my crate, I wrote perfectly valid code, right? Nothing would complain, and implement display for vec, and that's great. But then the Rust team would never be able to add any traits to standard lib. Like it wouldn't be allowed to be extended. So the orphan rules, or there are multiple like coherence rules, and orphan rules is part of that, is like it doesn't allow you to implement a foreign trait for a foreign type, because that's not coherent. So that's like orphan rules 101. I hope I get the thing right. All right. So this block here, I'm just gonna comment it out. Invalid. All right. Cool. Cargo check. Come on. Yeah, there we go. Now it's valid again. Get rid of that. Now, in this post, so what they're saying, all right, now you understand orphan rules, hopefully, or sort of the idea behind it. So no foreign traits for foreign types, because that would cause problems. They've somewhat relaxed this, right? So, here's a fun one. Yeah, actually using from would have been much easier. So what they're saying now is like, so they're allowing a nice little trick here that says, if you have a foreign trait that you want to implement for a foreign type that is parameterized, so it takes a generic that is defined locally, then that suddenly becomes valid. The reason for that being is that so the formal version of saying this is that damn it, I had a phrase and I lost it because I tried to simplify it. But more or less the idea is that type that you're defining locally would not be available to any other crate without that implementation being pulled in also. So coherence is still good, right? So all right, yeah. So the idea is that say we want to implement. All right, let's use from as an example instead. So instead of this, which is not valid, let's turn this into from. So from unit for vec. All right. Function from self for vec. So this implementation doesn't exist yet. We're going to say, what does it return? Returns a vec of that. Oh, hey, go get lost. To do. All right, so this won't compile. Unconstrained type parameter. Yeah, okay, fine. We need to get rid of that. And now we'll get a different error that says what can't compile. There we go. So studvec is not defined as current crate. And the type here, the type we're parameterizing it by, so a generic parameter from, is also not defined in a current crate. So I can show you the definition of from. Takes a parameter t. So it can be like, if we want to convert from IO error to this special type of error, then here's how to do it. And they can call that from. So it says like, okay, now in this latest version of Rust, so this was never possible. It still isn't possible. But now this thing used to not be possible, but is now possible. From bar for vec of unit or something, right? Let's copy this implementation. Like whatever is inside of it doesn't really matter. But then now this one is possible. I hope. Please work. Self-used and impl. What? Method from has a self-declaration in impl, but not a trait. Did I just copy the thing wrong? From T for self. Wait, how do I implement this? I've done this like so many times. Oh, from error, IO error. Oh, yeah. So hold on. So from bar. There we go. Yeah, I got it wrong. It's not into is the other way around. All right. So now this suddenly becomes possible. Bar, like that. And if we uncomment this one, then this was never possible. Like it still isn't. Right. So the way this works is this parameter, this generic parameter t, if that's a foreign parameter, so not defined in our current crate, then that still doesn't work. But now what's different in this patch is if that parameter is defined in our crate, then it will now work. So it, because you can't get this implementation if you get this struct, this type here, then this implementation comes with it, which means that anyone importing this also has this impl, so they will never conflict, essentially. So the orphan rules still apply, but they're just more flexible, which is nicer. Which brings us to allowing this, which I'll go into a second. So I've got a second laptop here, which I'm looking at, and I'm like monitoring chat, which is running out of battery. So I'm just gonna grab a charger real fast. Charger. Where is my charger? Yeah, there's a charger. Yay. Yay. Okay. So charger plugged in, calamity avoided. Does anyone have any questions about this? Does it make sense? Are people curious about what's going on? Yeah. So, like going over what Bots is adding, I saw them this week in person, where they sort of shared this idea, and now I guess they wrote the patch for it, and it goes through the process of like getting it tested. But the idea is, just briefly touching on this because it's been enabled by this thing, is raw waker. Before this, the only way to create a new waker, which is a thing you use inside of like futures, it's a callback that's a bit special for reasons. So it takes a raw waker v table, and this raw waker v table is like full of unsafe. So you create a raw waker by defining this thing, this giant thing full of pointers, and you combine that with some other value here, and like that creates a raw waker, and a raw waker can in turn be used to create a waker from raw. So the only way to create a waker inside of Rust, so this callback kind of thing, was to use raw waker v table, combine it into like the raw waker, then you create a waker from it, so from raw, and then you have the waker, and you combine that with another thing called context. And then once you have context, you can pass this into a future, which takes here the context param, right? So it's like many, many layers to go through. Now the plan was always, what Bots told me, is to have a way where you could create a thing from a closure. So like you can do something like let waker, not exactly this for sure, but the thing is like execute code here. So where you say like, if this waker is being executed, then this callback will fire, and there should be a very convenient way to enable that. So if we look here, is there a test somewhere? Is there an example somewhere that I can just use? Raw waker, wake by ref, raw waker, wake trait. Eek. I know it's in here somewhere because that's the whole point of this. Just trying to explain like what's new here and what's being enabled. Was it din fn? Function wake. Oh yeah, there we go. So now there's a trait wake, which provides, you implement wake and wake by ref, which is essentially to or it should be to, just do methods. Oh, I'm doing a terrible job explaining this. From arc, waker, wake, sensing, static. All right. Okay, I'm not going to be able to explain this properly. Not without like doing a little bit more research to explain it. But the core takeaway is that this trait defines two methods that you implement, and then this can be implemented for, I believe, a closure, which essentially, you define a closure and you give that as the waker, and then that just works. Something like that. Okay, that was a poor explanation. I'm sorry. But this whole thing about the core benefit, the big reason why this is cool, is that we can get rid of all the unsafe code related to it. Like if you have specialized needs where you actually have interesting things to do for all of this, right? Then the raw waker v table with the thing here, then you can populate all those things. But if you don't, which is much more often the case, just having a callback is much nicer. So Stepan added this recently, waker function. I guess this is the better one, where you say, okay, I want to create a waker from a function, and then you get a waker back. So this is almost exactly what that would be. It says like, hey, here's a callback that we turn into a waker, and that's all. This was taken from the, forget their names, but the Isaac, the person that built the Isaac HTTP client library, the wraparound curl. They came up with this, and then this existed, and Abutz was like, oh yeah, we always wanted to have this, but this way, and now there's a proposal for it, which is really cool because it was enabled by this week's 1.41 feature. So yeah, creating wakers should become easier in the future in the standard library, which is very exciting. All right. Implement wind waker. Okay. Actually, yeah. Okay, fair. Sorry, that's yeah. Yep. I'm just like trying to think like who actually cares about wakers, and generally it's only if you're like implementing your own executors. Like who implements their own executors? Like it's a fairly specialized need at this point. Coincidentally, it's been what I've been spending most of my time on for the last year. So it's very relevant to me and a handful of other people. But yeah, I don't know. It just got me very excited. There you go. Okay. Yes, great. So that's foreign traits with a little divergence into what that just enabled for wakers. Okay. Great. Let's take a look at, I guess, FFI stuff. I barely do anything with FFI, but that's the other big one. All right, let's read this. So this seems to be important if you like use Rust to interface with C, then this suddenly becomes very relevant. So here it says, more guarantees when using box-T in FFI. So starting with Rust 1.41, we have declared, also I think someone just subbed, I'm not sure, I think I heard a sound, thank you. So starting with Rust 1.41, we've declared that a box-T, where T size is now ABI compatible with the C language's pointer T types. All right, so if you have a sized box, so a box where the internals actually have a size. Oh, what's that again? I forget what size it is exactly. I know it. I feel what size it is, but I can't explain it in formal terms, or proper terms, I guess. Is now ABI compatible with the C language's pointer T types. So if you have an extern C Rust function called from C, your Rust function can now use box T for some specific T. Well, star T in C for the corresponding function. As example, on the C side, you may have, all right, so they go into explaining this. C header, struct foo new. All right, so this is a function that returns, I believe, a pointer to foo. I think, right. Yeah, so foo is allocated somewhere on the heap. I'm not a C expert, so I only like sometimes read it. It's also interesting. So I believe this is just a pointer to C somewhere, or to foo somewhere on the heap, which it returns. Yeah, so it instantiates a new thing. It doesn't take any arguments. void, I believe, means nothing. All right. And in order to delete it, it takes ownership from the caller knob when invoked with null. Great. Okay. And here we can define a box foo, which returns box new, and foo delete option box foo. Great. Cool. So I think what this means is it becomes easier to do stuff with heap values over FFI boundaries in Rust, which is a pretty neat thing, I guess, if you like have to do that, which I rarely do, but you know, that's nice. Yeah. Okay. Great. Note that while boxt and t star have the same representation and ABI, a boxt must still be non-null, aligned and ready for deallocation by the global allocator. To ensure this, it is best to only use boxes originating from the global allocator. Great. Okay. So there's some constraints around this that you need to enforce yourself. Important. At least as present, you should avoid using boxt types for functions that are defined in C but invoked from Rust. Great. In those cases, you should directly mirror the C types as closely as possible using types like boxt. C definitions just using T star can lead to undefined behavior. Okay, interesting. So you can't do like a double FFI winding where you go from, or again, not an expert. So the way I'm reading it is like if you have some type from C that goes into Rust, then you can't like put it back out to C if it's boxed, because that will just create undefined behavior. And this is okay because old FFI stuff uses unsafe everywhere, so that works. Cool. Yes. So I'm not gonna preview this. Like it's too much work, I think, at least for me, because we'll have to define a C file, and I don't know the compilation toolchain on Windows properly. Can't just GCC it. But yeah, if you're working with values on the heap, then this will make interop nicer, it seems. Bunch of gotchas because C, but that's great. At least possible now. Okay, cool. Yay. Moving on. Library changes. I think this is always like my favorite part because it's what I end up using like the most. The result map or and or results map or else methods were stabilized. All right, so let's see what they do. Result map or else. So what this does, applies a function to contain value, if any, or returns the provided value, if not. So function one's type TU, where U is default FF. X map or 42 v.len. 42. Okay, there we go. Yeah. So there's result, and if there's a result, you map it. Okay. So what this is useful for is if we have a thing. All right, I just understood what it does. So if we have an OK of 12 or something. All right. So we have value OK12, and we're going to make it a U8 for good measure, so the type system doesn't complain. So map or will do x of map or. Wait. All right. Yes. Debug v. Does this work? Park or run. Expected 2 parameters. All right. And then here, the second param can be 15. Expected function ones found integer. Function one. This is so interesting. X up map or 42. Oh, the default value goes first. All right. That's confusing for me, but it's fine. Counter type for parameter E. All right. Instead, IO results like that. And then let's remove that semicolon there, and then like let's run it again. That should work. Please work. Okay. There we go. Cargo run. Oh, come on. Does everyone see my bugs? The question mark operator can't be applied to bugs. Oh, there we go. Yes, of course. Expected nothing. Fine. Count infer type parameter for E. Oof, oof, oof. Results. Okay. All right. You know what? We're just gonna copy that. There we go. And then we can remove this, and we actually get to run this example. Now let's see what happens. Cargo run. Now that worked. All right. So what this does is U8 map or. So it's very confusing to me. Sort of like as a general thing is that this param goes first. It's more or less, so instead of saying map or, it feels like or map, or the or value. So if this type is error, if error E, then the default value is provided. And if OK T, then we apply closure. Does that make sense? But now it's been munched together into like a single operation, and it's more or less or map, but it's actually map or. So what we say here is like, if this value is an error value, then we will convert it into 42. But if this value is an OK value, then we will apply v.len, which is, I guess, useful in some cases. So that's what that does. And I guess map or else does the same thing. So default D, but instead of like giving it a const value, you give it a closure. So there, the first value becomes a closure, which says like, here is the default value for that closure. So instead of 42, it would, I don't know, like compute whatever thing with the error. All right. Okay. So that's kind of nice. It allows you to, on one side, so the map or else I think is the more valuable one, where you can do something like match value. So match value, okay, of T. Do something. To do something. So it's as if you were writing this in line, but instead it would be, you know, val map or else, or somehow these lines have been inverted. I don't get it. I hope there's some precedent, but otherwise, I don't know. It's confusing to me. I'll trip up on that probably. Where in this case you would handle E, handle error, and then here becomes T to do handle val, right? That's more or less equivalent. So instead of like doing this kind of thing, and then you continue ras.map again or whatever, ras.filter, whatever. This now becomes an inline block to do the error handling and the other handling. And then there's the map or variant, which is like just here, like here's a default value. We don't even like care about it. It's like static. it's inlined in our binary or something. Yeah. Does this make sense to people? Like what this does, what this provides? So that's, I guess, nice if you're like doing a lot of stuff with like functional style programming, like chaining iterators or whatnot. The map-RELs could be nice. All right, so the same goes for option. So instead of like a result, you can have a sum and none value, where on the one hand you handle the sum value, on the other hand you handle the none value. Flipped around. Yeah, there you go. Dot unwrap or default. There we go. So non-zero numerics implement from non-zero if it's a smaller integer width. Oh, that's nice. So you can upscale your from conversions. That's really cool. All right. So for people unfamiliar with Rust number types, we have quite a few. So there's the integers, such as U8, unsigned integers, signed, such as I8. There's the point numbers, decimal numbers, such as the floating point numbers. Float 32 is a thing, right? In addition to that, there's the non-zero numbers, such as non-zero U8, I believe it's called. Yeah, there we go. Now, these are various categories, and soon we might even have like a secret number or something, or like secure number, which has some different properties, but those aren't there yet. These are types that exist currently, and they go all the way, like from U8 all the way up to like U128, I believe. Maybe we'll get bigger ones later, but it doesn't matter. Non-zero numbers are kind of cool. So as their name implies, what they are is a number that cannot represent the number 0. So let's see how to construct one, right? So there's non-zero for all of them. So non-zero U128, non-zero floats. We don't have non-zero floats. That makes sense. So you can take a U8, you can convert it into an option of a non-zero U8 or new unchecked. All right, that makes sense. And the cool thing about this non-zero stuff is if you, all right, so the reason why they exist is for optimization purposes. So if you look at how numbers implement it, so U8 is like 8 bits. 1, 2, so it'll be 1, 2, 3, 4, 5, 6, 7, 8. And now in a regular U8, all of these numbers are used to represent the number. So it goes up until like a certain thing, because the number 0 needs to be represented. But if you omit being able to represent a 0, so you say, well, this value always needs to be initialized, then you have a free bit. And as it happens to be, is an option of a U8 is usually like 2 bytes wide. So it would be like the option on one side. So 1 byte for option, 1 byte for number. If you do an option of non-zero U8, then it just becomes 1 bit for option and 7 bits for number, which adds up to a single U8, non-zero U8, which adds exactly, so 1 bit for option, 8 bits for number equals 9 bits, so 2 bytes. And this is 8 bits, so 1 byte. Stuff like this is what this enables you to optimize for. So it's very specialized. But if you're like messing around with like very specific values, or you like have, I don't know, you want to do some representation then this is kind of like a nice optimization. And now what this allows you to do, so what they added, so that's what non-zero numbers are. And now in this patch, what they allow you to do is to have a non-zero U8, new 12 or something, right? So let's actually run this. Cargo run. What's the top level? Stud num non-zero U8. Stud num non-zero U8 new. Please run. I forgot to capitalize that. And run. Okay, there it goes. Right, so now we have a 12. That's a non-zero U8. If we initialize this to 0, then we'll see it panics. Or it should panic. Why does this work? Oh, maybe because we were debug X. Are we running it? Cargo run. Please panic. X none. Oh, okay. So yeah, just unwrap select none. Okay, yeah, that makes sense. So it gives us back like actually an option of thing because that's still like 1 byte, but whatever. Yeah, okay. That makes sense. That's kind of cool. Anyway, the unwrap, let's initialize to 12 so it actually doesn't panic. That's actually a really clever API design. That's very neat. So now we can upgrade a non-zero U8. Let y equals x dot into, and we're gonna make y the type stud num non-zero u128, and then this should work. Yeah, there we go. Cool. So before this patch, this wasn't allowed. And what they've done here is the equivalent of if you were to use initial like non-zero U8, so like regular integers. You can do something like let x U8 equals 12 or something, right? And then is u128, and it's 12 as u128, and then this works. Now a problem that occurs here is that wait, hold on. Yeah, there we go. Please work. Still works. That's fantastic. Now the problem is that the inverse is also allowed. So x 12. So let's flip it around where we say, and this is x as u8. And now this is also allowed. And the problem is if we initialize this to a very large number, then the way this conversion happens, right? So this is a number that has, how many bytes? I don't know, 12 or whatever. And then we flip it around. The way it will do that conversion is just by like chopping off a bunch of data and being like, here you go. And it still works. This is still valid, but in almost every case, this will be a bug, right? Because you have, say we have like 12, right? There, let's see if we can represent this number. Yeah, we can. Debug x. Well, this will actually lead to show the problem, debug x. So we're printing it twice out. Yeah, there you go. So let x equals that, and then we convert it to a U8, and now it's like something else, right? Kind of like garbage. Not garbage, but like not what you would hope it would be. Yeah. Like this conversion doesn't make sense. It's not undefined behavior because it's memory safe and you don't get memory corruption, but you do get bugs. Very likely. And it's perfectly valid, no lints, all good. So people have learned from that. So the way it works, like going from a U8 to a larger size is perfectly fine because memory, like data is preserved, and all we do is like give it more size. Like, oh, you need room to grow. But going the other way around, it just tosses out data, which is not good. So it's not allowed. And in this patch, what we see is they have allowed a one-way upgrade process to go from one number type into the other. Yeah. So what you would really want is, instead of like this just working, you would need an explicit unwrap. And if it's too big, like if it would lose data, it should lose the data, or maybe like not provide unstandard lib at all, and like have a different strategies in which you would want to do this. Which is why people are proposing or regularly bring up to get rid of the as keyword, because it does this translation. Anyway, that's cool. They've added that for non-zero types. Now you know what a non-zero type is if you didn't already, and what this provides. All right. Oh, and if people have questions, like, please interrupt. I'm just monitoring chat still. But no one has questions, which I guess is fine. All right, let's take a look. The weak count and strong count methods on weak pointers were stabilized. Cool. So weak count, strong count. It has something to do with the way references work on RC. So there's RC, weak. So not for arc. Oh, these methods return the count of weak, or strong RC and arc pointers to the allocation respectively. So let's check something real fast. So what this is weak count, sync arc, weak count. And this was added in 1.15. And this was added in 1.41. Cool. So what this does is RC, or like arc, already had a method called weak count, and now RC gets that same method also. Gets the number of weak pointers to his allocation. So there is a way to get a weak pointer from this thing, which I forget how that works. Neo weak upgrade on the return value returns RC. I don't remember the exact difference, but you can have a weak thing, which I believe doesn't keep the original thing alive. So RC is like a memory counter. What does it stand for? I don't want to explain this whole thing. Reference counter. There we go. Which counts like how many references to this thing do you have, and we'll keep the original value alive, but you won't be able to mutate it as long as like everyone has a reference, and then once references run out, it gets dropped. Because there's no way to like get it again. Blah 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 blah. And then a weak references, I believe they don't hold, they don't keep the thing alive. So you can keep a handle to that value, but that weak reference isn't counted as like, as long as that weak reference is held, you can't remove the thing, which is nice for observing data without I'm explaining this okay. So what a weak references does, it allows you to keep a pointer to a thing and sort of be like, do I still have this pointer or don't I? Without looking at the thing influencing whether or not that data gets removed or not. Whereas a regular RC or a regular arc does not provide that guarantee. Or yeah, it like observing the data will actually ensure that's kept around. So weak doesn't, arc does. That's kind of the point. That's a difference. And now you are able to count how many references you have. So strong references and weak references on arc, where I believe in here, strong count. Yeah, in 1.15, this was available for arc already, and now it's available for RC. Yeah, there we go. Yeah, they could have mentioned this, like, this was available for a while now on arc. Now it's available here. I know. I'm not going to critique the patch notes because they're fine. But yeah, I guess that is all there is on the patch notes. I wanted to share more stuff, but how long have we been going for? I think like 2 hours almost. 1 hour and 4 minutes. No, that's pretty good. Yay. All right. I think that's all I had for today. I guess we just ran throughout the whole patch notes in an hour, which sounds pretty good. Maybe I'll do one like next time, and I'll actually prep and read it before this. Oh, wait, we missed one. Maybe it now implements debug. Hold on. That's a pretty straightforward forward one. So maybe an init is a thing, like an option, but where the none value just says it's uninitialized memory, and it now implements debug, so you can actually look at it, which should make debugging stuff around uninitialized memory, there you go, debug, a lot easier. So you can actually be like, oh, is this value initialized or not, and like look at it. So we can actually even look how it's implemented. It says 1.41 f.pad type name self. I don't know where type name comes from. Type name, create any type name. All right, that makes sense. And then it takes the type name of self and f.pad. What's pad? Which comes from format pad. This function takes a slice and emits it to the internal buffer after applying the relevant formatting flag specified. Formatter.pad foo. How does this work? I have no idea. I guess it just says like, here's data and like do whatever with it, which is perfectly fine. Yeah, so now you can look at the data. You can look at the memory, I guess. I guess that's what this provides. You can now look at whatever memory is under the thing. Or is that accurate? No, you can look at the type name it's meant to be. Whew. Okay. I think that's it. Yes, it just gives you a type name. I've never used f.pad before, so I guess I got a little bit confused. But that seems nice. I want to know, what does f.pad do? So if we have foo, and we format it like that, that will format it like that. Interesting. Okay. And if we don't do that, wait, hold on, let's run this. I was saying goodbye, but now I'm like interested in how this works. So f.pad, format.pad foo, print line, f.format, and if we don't do that, formatter.write. So we can do, the way I usually implement these things is write, write, formatter, foo. Please compile. There we go. Left foo, right foo. Okay, right. Now it always becomes this literal. But what this allows you to do is have it be formatted with like a prefix or a 0x foo or whatever. I don't know how relevant that is for this specific one, but I guess that makes sense. So I guess if you're implementing your own number type, what you should do is not write, but format a pad. And then that's what they did here. Did anyone say pad? No one mentioned pad. That's fine. And so that's what they did there. And all it gives you is the type name it's supposed to be. All right. that seems useful enough. It doesn't look at a memory, I guess, because it could be uninitialized. But yeah, that's what that does. We can now figure out what type it's trying to implement. That's useful. All right. I think we have, now this time for real, we have all the patch notes done. Yes. That's it. All right. I think I think that's it for real now. Thanks everyone for tuning in. I'll probably put this up on YouTube tomorrow or something. So if you want to watch it back or share with friends, like and subscribe, maybe. I don't know. Okay, that's all. See you right. Thanks for tuning in, everyone. Look, made a very fancy screen. Looks like my blog. I wrote a bunch of blog posts if you're interested. So yeah, I don't know. That's it. Okay.